This video will continue our discussion of double integration by finding the volume of a certain surface over our region R. Typically we draw region R's, but looking at this one, I'm going to have, that's not tough to graph. We can get a rough one, but like, here, like what do we do to graph that? So as long as they gave me the bounds at y is above, what's above y and what's below, I don't necessarily need to draw a region as long as this looks the way it does as well. It's pretty obvious that the x is going on the outside and the y is going on the inside. I do have a trig node up here. That would be one that pops up a lot. It gets us out of quite a bit of integrals. So I would take a look at that, and then maybe your sine squared if you want to look up that one too. These are identities that make their way back in integration often. All right, so starting off, I see the 3 on the bottom. I'm going to go ahead and pull that third out, leaving me ln of y over y, and then I'm going to do y first. There are no x's, so I'm just going to go ahead and tackle the y. So this is y is e to the 3x, to y is e to the cosine x, and then our x's are going to run between 0 and 3 pi over 2. Okay, so I see all the y's there. Hopefully you can see this. This is one that just pops out. The u should be ln of y, because if I take the derivative of ln of y, I get 1 over y with the dy, and that takes care of that whole integrand for me. So I'm going to rewrite it. Got 1/3. I didn't change my x's at all, so I'm just going to rewrite those. And then let's go ahead and convert our y's to u's. These are nice with what we chose for u, because ln and e are inverse operations, so we just get a 3x and a cosine x. They just undo each other, leaving me what's in the argument. And then this is what's so pretty about this. This becomes a u du dx. Nice, easy integral. So let's take our integral. I'm going to see what we're going to do. We're going to do u, and it's going to be 1/2 u squared. When I take the integral, I'm going to go ahead and bring that 1/2 out, so I don't have to use another step to do that. So I get x equals the same boundaries they were before, and then I got u squared here. I don't need to do the 1/2 because I pulled the 1/2 to multiply with the 1/3. So I have u equals 3x, and u equals cosine x, so you can see where that cosine squared is going to pop up. And I still got dx. All right, I plugged this in. I got 1/6. The integral of x equals 0, x equals 3 pi over 2. And then I'm going to plug each one of those in. So I got cosine squared x, and then minus, I'm going to square 3 to make a 9, and square x to make an x squared, dx. At this point, it gets weird with u subs. Actually, it's not bad. Let's leave it as 1. Okay, so I'm going to change that cosine. This is 1/6, and we get x equals 0, x equals 3 pi over 2. And then I'm going to change that to a 1/2, 1 plus cosine 2x. That's that trig identity I wrote at the very top. That's where this comes in nice and clutch for us. 9x squared. We up the variable by 1, so it's 3. 9 divided by 3 is 3. And I got 3x cubed. That's going to line out with that. We already started taking our integral, so, we shouldn't. Okay, be very careful here. This is something happens, and I actually almost just went forward with it. I did not take the integral. I just rewrote it. So this is still 9x squared. Okay, cool. I'm glad I caught myself. Be careful of that. Just changing it doesn't mean that's what it is. Okay, so I'm going to separate this because I'm going to have to use a u sub for that cosine 2x. So let's just do it one term by one term. Let's do integral of x equals 0, x equals 3 pi over 2. And I'm going to get a 1/2 plus a 1/2 cosine 2x, and then a minus 9x squared. Now everything's multiplied out. I can just do it term by term. That's what I was meaning by that. I know I'm going to have a 1/6 on the very outside. I'm going to get a 1/2 x plus, okay, the 1/2 cosine squared. Okay, that's going to be, sine will give me cosine. So if I write down sine, and I know it's going to be a 2x, I just got to think about it. what's going to give me a, remember if I take the derivative, I do sine becomes cosine, 2x, then I multiply by 2x, so it's going to be a 2. That's going to have to come out to get a 1/2, so this is going to have to be a 1/4. Now double check that. I got cosine 2x, the derivative of the inside is a 2, I multiply that by 1/4, and I get a 1/2. So you can avoid the u sub, just think about it. If you need to do a u sub, just be careful because we're doing multiple integrations in one. So this becomes, I go up by 1, I get 3x cubed, and then all this is ran between x equals 0 and x is 3 pi over 2. Okay, so we'll plug those in. I'm going to go ahead and, now I'll keep the 6th on the outside. All right, I got a bracket. I'm going to put each one in parentheses. Okay, I got 1/2 times 3 pi over 2. That's just going to be 3 pi over 4. Plus, plugging in 3 pi over 2 into sine, but into times 2, that's going to give me a 3 pi. Well, sine of 3 pi is 0, so I get a 0. I'll put there for note's sake. And then I got a minus 3 times 3 pi over 2 to the third. And then the second, if I plug in x equals 0, if you notice all the way across, we get 0. All right, multiplying this out, we get, okay, some things are going to cancel there. I'm going to get pi over 8. And then we're going to have 1/6 times 3 times 27 pi cubed over 8. We're almost there. I got pi over 8 minus, okay, 3 over 6. That's going to be 1 over 2 times the 27 pi over 3 over 8. That's just going to be minus 27 pi over 3, pi third cubed over 16. The mathematician in me wants to go even a step further. I can get a common denominator. You do not have to go this far, but it does look nice to get one whole answer there as one term. Okay, so nasty integrals, but be very careful when you're using these trig identities to not do what I almost did, where I counted it as an integration, but you're just switching. So look for those trig identities. My advice is any that comes up in the homework, you write them down, and that goes on your note card in case I don't give them to you. I may give them to you, I may not. It really just depends. For the most part, I typically do, but to be on the safe side, if you get in there and it's not there, you're going to need it. That's what the note card's for. So whatever comes through homework, write it down. I won't introduce anything new.